In this video, we're going to talk a little bit about reviewing how to add and subtract fractions. We'll start with some constant fractions and then with some fractions of polynomials, i.e. rational functions or rational expressions. So once again, the algorithm that's used for adding fractions of polynomials is the same as the algorithm used for adding fractions of integers. If we're careful about how we write this down and what we're doing when we're adding fractions, which is constants in them, you will see that this translates very nicely to the variable situation. So the original problem is 4/15 plus 5/6 minus 2/9. We have to get a common denominator on these to add them together. They have to be equal size parts. Fractions can be thought of as parts of a whole, and so we need the equal size parts to add up or to count up. Okay, so to do that, to get the least common denominator, which is the least common multiple of the denominators, we want to have them in factored form. So that's what we're going to do first. Factor each denominator into its prime factorization. 15 is 3 times 5, 6 is 2 times 3, and 9 is 3 squared. Now we're going to write this down. This is a partial step. Here's the completed step down here. The first thing you do is rewrite it with the parentheses for the first numerator, second, third numerator, and a parentheses that we'll fill in a minute for the second to finish the numerators. And what we do is we need to find a common denominator, or least common multiple of these denominators. And what you do is, if they're all in prime factorization form, you just take every prime factor that appears, and it's part of the common denominator, and you take the largest power that appears anywhere. So if you look, well, there's 1, 2 here. There's 2 3's in this last one and 1 5 here. So it's 2 times 3 squared times 5, and we need that to be common all the way across. Of course, how do we get from here to here to make this work? We see what's in the common denominator that's not in the original. In this case, there's that second 3 and the 5, which means that we multiplied top and bottom of that first fraction by the second 3 and it's the 2, the second 3, the 5's already there and the 3's there, excuse me. So we multiply by 2 and a 3 in the top and bottom. There we go. So if we multiply by 2 and 3 here, multiply the bottom by 2 and 3, we get their common denominator. Similarly, what's here that's not in the original? Well, we've got the 2, we got one of the 3's. It's that second 3 and the 5 that we're multiplying the top and bottom by on the second one. And the third one, we have both the 3's. What we're missing is the 2 and the 5, so we multiply top and bottom by 2 and 5. Now, leave the bottom factored, but multiply out the top. 2 times 3 is 6, times 4 is 24, 5 times 5 is 20, 5 times 3 is 75, 5 times 2 is 10, times 2 is 20. And then we can use the fact that if they're all the same denominator, we can keep that denominator and just add the numerators with the appropriate sign there. So it's 24 plus 75 minus 20 for the numerator. Combine like terms and combine that together. Do the addition and subtraction in the numerator to get it to 79. And then you factor this and cancel, okay, to reduce it. Well, the denominator is already factored, so there's no point in multiplying it out yet. Now we want to factor the numerator. Well, it turns out 79 is prime in this case, so we can't factor it anymore. But if there was anything in common, then we would cancel it. And then finally, we might go ahead and multiply it out. And so now 3 squared is 9, 5 times 2 is 10, 9 times 10 is 90 for the denominator. And so 79/90 is the reduced version. So the steps are kind of written out here by the side, what they are, and then the illustration of applying it over here. But notice it's exactly the same steps here. So let's do another one with constant fractions. Okay. And factor the denominators. 12 is 2 squared times 3. 9 is 3 squared. 75 is 3 times 5 squared. Well, we need 2's, 3's, and 5's. And we need 2 2's, 2 3's, and 2 5's. So that's the common denominator. Okay. Well, let's see. We've got the 2 squared and 3. We need the other 3 and the 5 square here. We've got the 3 squares, so we need the 2 square and the 5 square there. And for the last one, we've got, we don't have any of the 2's, so we need 2 square. We only got one of the 3, so we need a 3. We got the 5 squared, so you don't need that. So this is equal. This fraction is equal to that one. This one's equal to that one. This one's equal to that one. So this equals is valid. Multiply the top together, 525. Multiply these together, 500. Multiply these together is 48. Write it as one fraction and just add the numerators, add subtract as indicated to get that. Factor and cancel. Really, the main thing is you just got to make sure there's no 2, 3, or 5 that'll cancel. It ends in a 7, so it can't be a, to be divisible by 5, it has to have an end in a 0 or 5. To be divisible by 2, it's got to end in a 0, 2, 4, 6, or 8. And to be divisible by 3, the sum has to be divisible by 3. 7 plus 7 is 14, plus 9 is 22. That's not divisible by 3, so this whole number is not divisible by 3. So it's not going to cancel, even if that would factor. So it's 997 over, well, just multiply the bottom out, and you get 900. Here's another one. Okay. Factor the denominator. Now the factoring is a little bit harder on these, so we need to maybe have a little factor tree going off on scratch paper somewhere. But I have them factored out. Hopefully I didn't make any mistakes there. You could check it. And to get the common denominator, let's see, we have 4 2's. We've got 2 is the biggest power on 3, 2 is the biggest power on 5, and 1 is the biggest power on 11. So that's the common denominator. Okay, what's missing here? 2 2's and a 5. I guess that's what goes here. What's missing here? A 2, a 3, and that's it. And the last one, 5 and 11. Multiply these numerators together, we get that. Get a common denominator here, make it one fraction, put the numerators together, add and subtract there, we get 31,005. That factors as 3 squared times 5 times 13 times 53. Now we see we can do some canceling. The 3 squares cancel and one of the 5's cancel. And then we can see this is clearly reduced because this is all prime numbers in the top and bottom, and there's nothing that will cancel. So that's a reduced fraction. And then we just clean it up by doing 13 times 53 is 689, and 2 to the 4 times 5 times 11 is 880. Okay, notice over here on the right now, it is exactly the same steps, that it's exactly the same algorithm that is used for adding fractions, where there are variables, polynomials in the top and bottom. The only difference is instead of factoring integers, we're factoring polynomials. So use FOIL or anti-FOIL factoring here. That's x plus 2 times x plus 1 for the x squared plus 3x plus 2. And the x squared plus 4x plus 4 is x plus 2 squared. Treat the prime polynomials just like we did the prime numbers over here. So we see both an x plus 1 and an x plus 2. And there are 2 of the x plus 2's here, so we need a square on that. What do we do from here to here? We multiply top and bottom by x plus 2. From here to here, we multiply top and bottom by x plus 1. Multiplying these, just like multiplying out here, but now we're multiplying polynomials, so we do some FOIL here. X times x is x squared, 2 times 3 is 6, 3x plus 2x is 5x, x squared there, negative 5 at the end, negative 5x plus 1x is negative 4x. Rewrite as one fraction with that same denominator and just add the numerators together. Combine like terms here, x squared plus x squared is 2x squared, 5x minus 4x is x, and 6 minus 5 is 1. And then we see if we can factor that out and then cancel. That one doesn't factor very nicely, at least not into integer coefficients, and so there's a good version for the final answer. This next one is similar. We don't worry about the numerators right now. We just factor the denominators. And we factor that. Anti-FOIL factoring is x plus 2 times x plus 3. This one factors anti-FOIL as x plus 2 times 3x minus 4. And then we get our common denominator. It's going to have an x plus 2, an x plus 3, and a 3x minus 4. So multiply top and bottom here by 3x minus 4. Multiply top and bottom here by x plus 3. Okay, do FOIL, distribute, multiply this out. 3x squared plus 8x minus 16. And here this is 2x squared plus 3x minus 9. So it's the first numerator minus the second over the original common denominator. I can drop the first parentheses, but when I drop the second one, I have to distribute the negative, changing all the signs. So it becomes a negative 2x squared, a negative 3x, and a plus 9. Combining like terms, we get 1x squared, and 8x minus 3x is 5x, negative 16 plus 9 is negative 7. And then you factor and cancel. This one doesn't factor real easily, so we just leave it. When I say easily, I mean it doesn't factor at all using integer coefficients, and so that doesn't reduce. So there's our final answer. All right, one more example. Here we have another one. This is x plus 2 times x plus 3 for the denominator. This one is x minus 2 times x plus 3 for the denominator. And the last one is x plus 2 times x minus 2. So if you notice, we have an x plus 2 and an x minus 2, and we have an x plus 3. So those are our three factors for our common denominator. The one that's missing here is the x minus 2, so I multiply top and bottom by x minus 2 to get our common denominator and equivalent fraction. Here I want equivalent fraction. The missing part is the x plus 2. So multiply top and bottom by x plus 2 up here to get this equivalent fraction. And the last one, the missing factor, is the x plus 3, so we multiply that in the top and bottom. That gets everything to the same denominator. Distribute here, 3x minus 6, 5x plus 10, and negative 5x minus 15. Here I went ahead and took the minus here and brought it up with the 5. It made that plus. That's what happened there. So now when I put them all together, I don't have any parentheses in the numerator. Just add that, and still a common denominator. Factored, leave it factored. And then let's see, 5x minus 5x is 0, plus 3x is 3x. 10 minus 15 is negative 5, plus negative 6 is negative 11. And then you factor and cancel. So that's a quick, very quick review of adding and subtracting fractions. I refer you back to my algebra notes and algebra videos for more examples and me going through this quite a bit more slowly than what I just did. In our next video, we're going to talk about how to reverse this, how to start with something that looks like this, 3x minus 11 over x squared, x plus 2, x minus 2, x plus 3, and turn it into something, well, not looking exactly like that, but looking like a sum of different things.